power is defined at the rate at which energy is converted from the electrical energy of the moving charges to some other form. Example, heat, mechanical energy, or energy stored in electric fields or magnetic fields. The flow of electricity carries energy or power from one place to another. This energy can be initiated at one point and used at another. In the electrical circuit, the energy is put in by pumping the electrons from a low voltage to a high voltage. We can recover the energy by letting it fall from a high voltage to a low voltage. In the water flow analogy, this energy is converted to useful work by turning a water wheel connected to a saw. There are two ways in which we can increase the power of the water wheel: by increasing the height of the waterfall, a greater difference of potential and therefore higher voltage, or by increasing the flow rate, higher current. We can understand power as an electrical term using the water flow analogy. In the water flow analogy, the pump represents anything that puts energy into electricity, like a generator, a device that converts mechanical energy to electrical energy, or a battery, an electrical storage device, or a microphone converting sound waves into electricity, or a photovoltaic cell, which converts light to electricity. The water wheel represents a device that converts electrical energy into mechanical energy, a motor producing mechanical rotation, or a loudspeaker producing sound wave energy. Here, let us refer to the water wheel as a motor. When the man pumps water, the water which flows through the water wheel forces the saw to rotate and perform a useful task, cutting the wood. When the saw is removed, water continues to flow across the voltage drop at the water wheel. The only change is that no useful work is performed. Here, the water wheel is now simply the equivalent of a resistor. The energy put in by the pump is dissipated by the friction, resistance. In an electrical circuit, any working device like a motor may be replaced in a circuit by a resistor. This has no effect on the electrical circuit except that the resistor gets hot, and work that might be done is instead dissipated as heat, thermal radiation. Heating elements and incandescent light bulbs operate in this manner.